Assalamu alaikum. My name is Hanan Ahmad and my registration number is 21TE25. Today we are going to discuss DSP Lab 4. So the question number 1 is difference between signal and system. In signal processing, a signal is a time varying or a quantity that carries information. It can be electrical or optical in nature. While on the other hand, a system is a mechanism that processes the input signals to produce an output. The characteristic of a signal is its information content, while a system is defined by its behavior in transforming or manipulating signals. For example, an audio signal like music is a signal, while a speaker or amplifier represents a system that processes this signal to produce sound. So the task B is linear time variant systems that play a crucial role in digital signal processing. Explain. So the answer is linear time invariant systems are fundamental in digital signal processing due to their mathematical simplicity, adherence to the superposition principle, and efficiency in frequency response analysis. These systems exhibit consistent behavior over time and possess linear and shift invariant properties, allowing for straightforward mathematical representation. And the superposition principle enables the analysis of complex signals by decomposing them into simpler components, while the task C is different methods of our signal decompositions. So, common methods for signal decompositions are impulse decomposition, step function analysis, even odd decomposition, and Fourier analysis. So, the first one is impulse decomposition. It involves expressing a signal as a sum of scaled and time shifted impulses, while the step function analysis break down the signal based on their responses, and the even odd decomposition separates signals into even and odd components. And the last one is Fourier analysis. It decomposes signals into a sum of sinusoidal components, revealing their frequency content. These methods play a crucial role in signal processing, allowing for a better understanding of signal characteristics and facilitating the design of filters and processing techniques. And the task D is what is convolution and its role in digital signal processing system. As convolution is a mathematical operation that combines two signals to produce a third, that is resultant signal, representing the integral of pointwise multiplication of input signals. In digital signal processing, convolution plays a crucial role in applications such as filtering, signal processing, and system analysis. It is fundamental for understanding how signals interact with systems, enabling tasks like convolution filtering to extract specific features or analyze the response of systems to input signals, making it a cornerstone in various DSP algorithms and applications. In task E, when do we correlate the signals? So we explain the correlation of two signals. We correlate two signals when we want to measure the similarity between them or identify a pattern of interest. Signal correlation is crucial in communication system for demodulation and error detection, radar and sonar for target identification. So in the task 1, first of all we define a function of convolution graph. Then we assume two variables that takes input from users as x and h, while y is the condition. So basically we have two signals that is given by a user. So we have to convert that two signals. For this we use figure command. After this subplot 3 comma 1 comma 1, as we have to draw three graphs in one frame. So after this we use stem command. After this we title that graph. Again we use a plot command to draw the second graph. After this we use stem command to draw discrete function, also titled this graph. After this subplot command is used to draw the third graph, and stem command is used in title this graph. At the last we use AND command. So when we simulate this code, we obtain these output. As we can see, we obtain three graphs. First one is signal 1, input signal X, that we named as X. The other signal is H, while the output, basically it is the output, that is convolution of these two signals. In the task 2, we also have to do convolution. For this, first of all, we define a function. For this, first of all, we assume t start, the starting time, that is t1 plus t2, while t end is the ending time, t1 end plus t2 end, while the difference of this time range is t1 minus t1. After this, we perform convolution using flip and slide methods. For this, we use for loop, and after this, we display the current result. For this, we use figure command, and then stem to draw the discrete graph of the function. Label the x-axis as time and labeling the y-axis as amplitude, and title the whole graph as convolution using flip and slide method. After this, we use axis as range of t start to t end. We own the grid. After this, we use fast command and end these function. So in the next step, we have to call the previous function as time 1 is, that is starting time is -1 to 1, while the condition is x1 is equal to exponential of minus t1 की power 2, t2, while t2 is ending time -2 to 2, and x2 is equal to t2 of power 2. After this, we call that function, that is convolution flip slide. When we simulate this code, we obtain these output. As we can see, there is starting time is -3 to 3, and these signals are convoluted by using flip and slide method. So in the task 3, first of all, we define a function named as my convolution x comma nx comma h comma nh, where nyb is equal to nx of 1 plus nh of 1, and assume give condition of nye, where ny is the condition range, where y is the function that we have to convolve x and h. So we let x is equal to the following array. After this, we use a range of -6 to 4, and let h as these given array, and the range for h is -1 to 4. So at last we have called the function of my convolution. After this, we use stem command, that is used to draw discrete function, title these function. When we simulate this code, we obtain these output. As we can see, this is response of a system to an input signal. So in the task 4, first of all, we define two variables named as h and x, and assign the following array for this, where y is the condition, that is we have to convolve x comma h. For this, we use ny command, that is range of length of y is equal to 0 to -1. Subplot command is used, then stem and title these graph, and subplot command, and then we use stem command to draw the function, entitle that response named as impulse response. After this, we use subplot command, then stem and title these function as output signal. After this, x shifted array, so we shifted the x array, and y shifted. Then we also use subplot command, then stem, then title as shifted input signal. After this, we use subplot command, and after we use stem and named as output signal for shifted input. When we simulate this code, we obtain the following output. As we can see, it is the input signal, and these are the impulse response, and the output signal is that. The output signal is convolution signal of these two signals, input signal and impulse response. And the last one is shifted input signal, and this is the output signal for shifted input.